So now that we have the gearbox itself, we can go on to our next part. So instead of adding parts together, stacking them, you really want to keep them all separate. So what we do here is we go to this plus sign for a new element, we go create part studio, and this creates like a whole brand new sort of fresh tab for us to use. We're going to rename this. We're going to make this the 2.875 inch wheel. Um, banebots. Good. Okay, so we're going to do a new sketch. We're going to hit N. We're going to click in the middle here. We're going to draw a circle. And instead of extruding this shape and then doing a brand new extrusion to make the hole, I can just predefine the hole right here. So let's make this 2.875, and let's make this 0.5. Nice. So now we have the hole sort of all set up right here. Now, in reality, the banebots wheels, I think, have a hexagonal hub. So we can model that. Basically, what we have to do is go up here to inscribed polygon. Do we want inscribed or circumscribed? Well, let's just see. Yeah, no, that's good. Okay, so by default, this oh wow, you can change the number of sides. So you can drag that across, and then it wants to know how many sides the polygon has. So I don't know if you wanted a decagon, you could do that, octagon, but we want hexagon. And see how this has a construction line and then actual lines. So really, what's defined? Let me get rid of this circle here. Really, the thing that defines the diameter of this is the inscribed circle here. So we want to dimension that. So 0.5. So that means that you can pass a 0.5 inch shaft through the end of this. And I think that there's actually a larger hex hub, because the hub has to have thickness. So something we can do here is, let's say the hub is, I don't know, 0.25 inches thick. We can actually offset all of these lines. So if we go over here to the offset tool, and we click one of these lines, and we click the other line, and the other line, and the other line, and the other line, and the other line, this will pretty much make this shape except bigger. And it's smart enough to know that all the vertices come together. So actually, I think 0.25 is a little too thick. Maybe it's more like 3/16 of an inch thick of a hub. I think that's more reasonable. Maybe even an eighth. I don't know. Maybe an eighth is too. I don't know. I don't have the wheel in front of me, so I don't actually know what the dimensions of the thing are. But basically, now that we have this sketch, right? So what we really want to extrude is this outer surface, right? We don't want to leave the stuff in the middle. So what you should do is select these in the bottom. And make these into construction lines, because they're not the things that you really want to extrude with or remove material. So let's go ahead and do that. Let's extrude. Let's do remove. Oh, I'm sorry. Because we drew the shape, we're going to just regular extrude. Yep. Okay. And it's 0.8 inches thick. Nice. So this is like the basic shape of the wheel, right? But the wheel doesn't actually look like this. It's sort of got this rim. Let me see. Banebots wheel. It looks like this, right? it's got this raised boss region. It's got the actual rubber on the outside. So there's this part where it kind of dips in, isn't there? And it's kind of got this radius, this fillet. So let's go over here again. Let's go back to this surface. Let's put another sketch on. And I'm just eyeballing this here. This doesn't actually matter in terms of like mating parts together, but this is just about what I see. Maybe this is a little bit closer, sort of like that. And whenever you don't know what the dimensions of something are, you don't have to dimension it, but I'm just going to for the sake of simplicity here. So, this one. Oh, here's something else you can do is instead of just defining the diameter of something, you can actually define how far apart things are. So you click on this circle, and then you click on this circle. See how it gives you distance? So now what you can do is you can say, instead of saying, oh, I want this circle to always be 1.5 inches in diameter, you can say, okay, I want this circle to always be 0.375 inches away from the edge. And that's also really powerful because you don't have to absolutely define things, so it saves you a lot of time. It's all about design intent. I think I've mentioned this word before, but basically you have to think to yourself, okay, if I were to change the dimensions of this somehow, how should everything else update? So, like maybe the thickness of the rubber never changes, right? Maybe it's always 0.375 inches. So if you were to change the diameter of the wheel, and then you were to leave the plastic part, the same 1.5 inches or whatever it is, it's not going to change in the way that you want it to. Like, that wasn't your intent. So you should always be thinking about your design intent. Don't just dimension things and say, yeah, that's how big it is. Try to dimension things in a way that reflects exactly what you want the shape to do, even when things change. So it'll make more sense the more you use CAD. That's kind of a high conceptually a little bit advanced, but it's good to be exposed to it early on, because at least when I started using CAD, I was that guy who would put numbers in for everything, or not even define the sketches. Like, I would just draw stuff, and I wouldn't even put numbers in, and that becomes like a total nightmare later on when you want to move stuff. So don't learn from my mistakes. Don't be like me. So let's make this maybe like 0.125 inches, and see that this looks a lot more like this. So let's put fillets in here. So you can fillet an entire edge. Any edge you can fillet. You can go crazy with the fillets. Looks pretty nice sometimes. So kind of go like that, kind of go like that, kind of go like that. Why not? Is this one filleted? Not really. Just the insides. Okay. Cool. So, all that hard work we just did with this filleting and the extruding, why don't we be lazy? Because being lazy is not a bad thing. Oh, look at this. This is a good little teaching moment here. So, because I didn't make the part along this plane symmetrical, if I tried to mirror it, it would not mirror it in the proper way. So what we have to do is now we have to define a new plane. So I have to go to plane up here. And now defining a plane, there's a lot of different ways you can define a plane, but here we want a mid-plane, which means that we tell it two planes that we have already, and it will put a plane right down the middle. So let's hit mid-plane. Let's hit this surface, right, and this surface, because that is what's going to give us straight down the middle. So now we have a plane right down the middle. And now what we can do is we can go to our mirror feature here. And I think we may need to do remove. I think it's remove because we're taking material away. Actually, I don't know. Let's do add. I actually don't know what the difference is here. Entities to mirror, right? So we want our extrusion. Maybe it is new. We want our extrusion, and we want me a second here. Oh, no, we don't want a part mirror. That's where I'm going wrong. Feature mirror. I have no idea why Onshape did this. For some reason, they make part mirror the default. Makes no sense. Just feature mirror. It should always be feature mirror. I so rarely do use part mirror that I don't get why they even put it in there. But anyway, you see how this already exists and it's got an error. That's because I tried to make it and it didn't work. So you have to delete that. Okay, so go to feature mirror. Hit extrude. Hit fillet. And now it wants to know what plane. So we're not going to select this plane, the big one. No, we're going to do the new plane, plane 1. And we're going to hit OK. And now it's reflected about the midpoint of the entire surface. Cool, right? So now we have a symmetrical wheel. Nice, so that looks really good. Although it does look kind of big. What is this, 1 7/8? Yeah, that almost looks too big, doesn't it? What does a 3-inch wheel look like? This is more what the 3-inch wheel looks like. Okay, so let's go back to our original sketch. And see, this is why SolidWorks, or sorry, Onshape rather, is just so great, because you can, if you constrain things correctly, you can go back into a sketch and change this to 0.125 inches, make it smaller, and everything subsequently will update. Okay, so another thing that's really cool is if you think you've made a mistake or you want to go back in time but you don't want to delete everything, you can use the rollback bar. So if you drag this bar backwards, it will unbuild, so it won't delete it, but it will unbuild your features. So like this just got rid of our mirror, but if we drag it back, now you can see we have our mirror. So it's sort of like going back in time. It's like a little time machine. So if we want to get rid of our plane, now our plane is gone. If we want to get rid of the fillets are gone. And using this, you can kind of see if you have an error or like how something was built. You can try to figure out what went wrong. Or you can even add features back in time, and then they'll propagate forwards. So rollback bar can be really helpful, especially if you make a mistake and something is not, or you make a change or something and it's not updating properly. So yeah, that's our wheel. Nice. Okay, so let's move on to, let's do the motors. Okay. Motor's gonna be a little bit harder because I don't have any dimensions for them really, but we'll try our best. So we're gonna rename this. We're gonna call it RS540 motor. Great. I like to start with the top sketch usually. Just hit N. Whoops. U normal 2. There we go. Sketch, circle. If I remember right, the diameter is like what did it say here? Diameter 1.41 inches and length 1.91 or 97. 0.41. And we're going to extrude 0.97. Oh, something didn't go right there. 0.97. There we go. And you can kind of see the shape of the motor is not what it looks like right now. It's got this little part that kind of sticks out. I wonder if that's part of the overall length. I don't actually know. We can search the internet for this. See if it gives us a data sheet. Dimensions. There we go. Very cool. Actually, so yeah, it's a little small though. There we go. That's useful. Okay, so this is like, the schematic for exactly 50 mm's in inches. You're going to be doing this a lot because because the world is divided. I I um I would advocate for the metric system in general, but because a lot of U.S. manufacturing and industry uses the imperial system, it's better to use the imperial system and get used to it than it is to totally adopt the metric and then try to force it. Um, there's a really interesting story about um, Russia in the Cold War trying to copy United States bombers, um, and part of the reason why they were not able to do it efficiently was because if you go from 1 millimeter to 2 millimeter to 3 millimeter, the increments there are very different from our English system, where we go from like 14 gauge to 16 gauge to 18 gauge, and the exact thickness of the material that they were not did not have in a standardized thickness. Um, it actually made it really difficult for them to copy the airframe and everything. And they it ended up costing them a lot of money to try to build the exact same plane, basically because they didn't have, their 2 millimeter was not, I don't know what is 2 mm in inches. Their 2 millimeter was, there's no like English equivalent for the 2 millimeter, or there was no millimeter equivalent for 0.125 or something like that. So um, ended up giving them a lot of issues. Anyways, tangent aside, um, I would say just use the English system, and then when you have to do metric, that's something else that's good about this program, is that you can give it millimeters and just type it into the dimension bar, and it'll recognize what you're doing. So let's make this look a little bit more like a motor. Um, it's got this filleted edge on the front. It's got this little part that kind of sticks out, and the back of the can kind of has an indentation and little prongs that come out the back. So looks like this is 4.5 millimeters out. So let's go view normal 2. We'll do sketch. We will draw like this. And I wonder what the diameter of that was. Let's close this because we don't need that anymore. Don't need that, don't need that, don't need that. Diameter 13 millimeter. So what we can do is we can just type 13 mm, hit enter, and that's 0.512 inches. So that's what shows up there. And then I think 4.5 millimeters, right? Weird, I don't know why that didn't enter. Strange. Okay, there we go. And this looked filleted to me, so we're going to fillet this. Maybe just a bit longer. Maybe like 0.25 fillet. Yeah, that's good. And then we'll do a different fillet because this is probably a smaller one. 1/16. Yeah. Good. And then we kind of go back here, and this kind of looked like, this sort of had an indentation sort of in the can. It's not quite all the way back there. I don't know, 0.125. We're removing it. Yeah. Okay. Actually, that looks kind of funky. I don't know why. Maybe this should be smaller. Maybe this should be closer. Okay. Yeah, sure. Why not? I think a lot of the times when you're doing CAD, you just gotta say to yourself, "Yeah, it's good enough." All right. Pretty good. So let's leave it at that. We really don't need more detail than this for people to get the point. This is a motor. We don't have to put these slots in. We don't have to put that flux ring and the tabs. I guess we should put the tabs. Looks like the tabs are maybe they're 0.5 millimeter thick, and they're 3 millimeters jutting out. So, here's a good opportunity to teach. Okay, so I'm going to draw a line, and I'm going to make this for construction Q, and then I'm going to make a rectangle, stuff up. I don't actually know if that's the dimension, but then this accidentally came out as a construction line, which I don't want, so we got to select all of it, and then unclick the construction. And now we're going to extrude. We're going to click on this solid. Yeah. Okay. Now this is 4.5 millimeters. No, sorry, 3 millimeters from the edge of the can. So I have to go to the edge of the can here. So we indented this a bit, right? So that wouldn't give us the right dimension if I just typed in 3 millimeters. So what we have to do is we actually have to do, instead of doing blind means I'm going to give you a number, you're blindly going to go out that number. What we have to do is first we should do up to face. Yes, up to face. Now we can tell it to go up to this surface right here. So that those will be equal, they're flush. And now we can hit offset distance. And we can hit the reverse direction here. Now what this is doing is it's saying, okay, take that sketch, go up to that face, and now I want you to add an extra whatever it is. So instead of doing 1 inch, we're going to do 3 millimeters. So let's do that. So now what this is from here to here, we can see in the, alright, so it's because it's in inches. You know, the z direction is 3 millimeters, meaning that it's 3 millimeters from this endpoint to this face, and then it's whatever it is on the inside. So again, that's a really good feature, because then this feature could change. You know, we could make this different, right? So let's say that I wanted this distance to be smaller. So I go to the extrude where I did that, and I make it, instead of 1/16th, I make it 1/32. Make it smaller. It doesn't matter that I just made that smaller. Okay, if we had just done a blind distance, or like sum them up, it would change the relative distance from here to here. But now we can see the relative distance has stayed the same. So again, that's just design intent, right? So you know, obviously in a perfect world you would define everything, you know, and everything would stay the same. There would be no changing of dimensions, but the reality is sometimes stuff changes. So now what we have to do is mirror this, because there's 2 of them. Let's go mirror. Let's go to that extrusion we just did, and we don't want part mirror. Again, Onshape is kind of stupid for that. We go to front. It's the mirror, we got to select the front, and there we go. So now we got 2 of these on either side. And this is what we solder the wires onto, so that we can, you know, give power to the motor. Nice. Okay. So we got 3 parts down, and only a few more parts to go here, I think.